So let us take one example to illustrate the entire merge sort procedure. So we will apply the divide strategy. We will divide the entire array, and then we will also apply the merge procedure. So let us see that how the merge sort procedure work onto this example. So let's say we have an array with the element 5, 2, 7, 9, 12, and 6, and just we want to sort applying the merge sort procedure. So if you remember the merge sort algorithm, first we need to find the midpoint. So just keep in mind, when we call the merge procedure, we need to pass three parameters: the array, this array itself, the p value, that is the first index and the last index. So here the first index is 0 and last index is 5. With index 0, 1, 2, 3, 4 and 5. So you can say your p equals to 0 and r equals to 5. And when you find q will be 0 plus 5 by 2, that is 2, because we are finding the floor value. So that means we are able to find 5, 2, 7. This is our first array, first division, and the second is 9, 12 and 6, because it will go from uh, p to q and q plus 1 to r. So now this is 0, this is your 2, this is your 3 and 5. Now further you will divide this. This is your first part, second part. Now again when you divide, you will do p plus r by 2. So what you will do, you will do 0 plus 2 by 2, that is 1, and you will do 3 plus 5 by 2, that is 4. That means now we are able to divide our array in such a way. This will be 0 to 1, so we have 5 2 here, and here we have 7. Here we have divided in two parts, that is 9 and 12, and then this is 6. Because it is already in array of size 1, so we will not further make a call of merge sort from here onwards, but here we have to make a call. Now why we are not being called? Because we have a condition p must be less than r, but here we have only one element, so p and r is the same thing, so this condition is not satisfying, so we will exit from here. So this is actually exit condition. We will not going to make a further merge sort call here, because p is not less than r here. Okay, this is not less than r, but here it is still satisfying. So now onward you will observe that it will p is 0, and what you get 1, and here is what 3 and 4. So when you make find a q is 0 plus 1 by 2, that is 0 only, right? And here you find 3 plus 4 by 2, that is 3. So you will further divide into 5 and 2, and here you divide 9 and 12. So now it is not going to make a further call, it will going to stop. Now what is happening? Now all the division is finally done, and now we will see that how the merge is working. So every time when merge is called, you need to make an auxiliary array of the size of the actual array. So here you are having this we have 5 and 2, so we have to merge these two. Okay, so we have this actual array, actually means we are actually working on this part, and we need to combine them so that it will be sorted. So you will make one temporary array, left and right. You will write here 5 and you will write here 2, and then you will apply this logic as we have discussed already in our previous slide, and then you have to merge you have to write this in this array A. Okay, so you will compare these two values, whichever is less, that will be written here. So you will going to write here 2. So what you will get, 1 2 3 4 5, 1 2 3 4 5 and 6. So these are index 0 1 2 3 4 and 5. So when you apply the merge procedure, what you get? You get this 2 and 5. So actually you are able to get this sorted, right? Then now this is sorted. These two elements get sorted. Now you will apply the merge with this and this. This and this you apply merge, and what you get? This is 2 and 5 sorted, and then when you apply this merge, you get 2 5 7 sorted. Okay. Similarly, when you are working here, you will apply the merge procedure to get it sorted. You will get 9 and 12, and you will get here 9 and 12 like this. And then you will apply sorting with this 9 and 12 and the 6. So what you get? You get 6 9 12. So actually it is going to change like this. So I am going to write it here. It is going to give you this thing: 2 5 7 will be 6 9 12. Okay, now we have this part. Here we have already sorted this. 2 5 7 is sorted, means this part is actually becomes this like this: 2 5 7, and here we already get this part: 6 9 and 12. Now we have to apply the merge procedure to sort this two things. So that means now we have this part and this part, and then we have to apply merge procedure to get this entire array sorted. So for this, what we will do, we will take one temporary array L. We will copy this element here, 2 5 7, and also we'll take one more array and we copy this element 6 9 12, and then we apply the merge procedure as we discussed. We will take some variable. We will take I, that will iterate through L array. We'll take J, that will iterate through R array, and we will take K, that will iterate through A array. And then we compare L and R indices. Whichever is minimum, that value is going to be written here. So when you compare these two, so 2 is minimum, you will write 2 here. This is already the correct position. Whatever the value you are writing, you have to increment that index. So it means I is here, now I moves here, but J is still pointing to this location, right? So now you have to compare these two. Now whenever you write the value from any of the array, every time the k will going to increase. Now the k is pointing here, so means the next value which you write, it goes to this index. So when you compare 5 and 6, you will find that 5 is actually less than 6, so you are going to write 5 here, 5 here, and it will move here. Okay, now because you have written this, so it will move here 7. Okay, now you compare 6 and 7. Now you will find that 6 is less than 7, so you are going to write 6 here, and you will observe here now it is going to sort it 2 5 6. Okay, and now because you have taken the value from this array, that means now you points to next index. Now it will be comparing with this. So you will observe that when you move in this way, you are going to get your array sorted. But one point to note here, we need to make some changes here to be fully implemented. Now let's say when we have finished up to this much, now what is happening, let me do one more step, then you will understand. Now we are comparing this and this. So what do you observe, that this is actually minimum, so you have to write this 7 here, and your index will be moving here. Okay, now this all iteration of I has finished, means you have taken all the values from I, only this array is remaining. So whenever you reach to situation when one array is finished, then there is no need to make comparison. You simply copy all the values from the other array, because it's already sorted, this is already finished. That means the remaining values need to be simply placed in the remaining position. This is actually required. So how can we implement this part? So if you go here, you can write this condition: L of I is less than R of J. Then if L of I value is less than R of J, means if this value is less than this, then write the value of L into the array. This is what we are doing. And also, if this value, means this condition must be true, and also along with this what condition must be required? I must be less than n1. N1 is the size of the array. So what is required? Either this condition must be set true, means this value is much less than, and at the same time this ith index must be less than the last index, means there is still more element existing. If there is more element existing, then only there's a meaning to compare, write the values from this to the main array. Otherwise there is no meaning of doing this thing. So what we are doing, we are saying that L of I must be smaller than Rj at the same time, and also I must be less than n1. Then only we are going to this doing to this. Otherwise we simply go to the else part and we write all the values of R to A. Okay, now this is one scenario. So instead of writing only this part, you can make this part. I mean, this condition plus this condition both must match. Then only you are going to write the values from left array to the main array. Otherwise you will simply write all the values of right array to the main array. Now there is the other situation also possible, that instead of this array may finish earlier, this array may get finished earlier. Okay, this is also possible. Let's say all the values of this array may be small, and this array, for example, I am going to extend this. Let's say this is 70, and let's say 50. For example, this is 50, this is 70, right? In that case, what is going to happen? You take you take this value, then you take this value, you take this value, you take this value, and this array got finished. And that means now whatever the value is remaining here, you have to simply add it to the actual array. So to match this condition, what you will do here, we can say or the j is more than n2. What does it mean? It means either the left array is not completed and the value of this is less than this, then you can write the value from here. Otherwise, if this value, if the index of our array has been finished, then you take all the values from L and write it to A. So we need to just add just little more logic to it, and it will be able to implement through a program. So let me write the entire logic here. So what we are doing, so what we are checking, this condition and I must be less than n1. These two conditions must match. Okay, this is first thing. Or means this must be together, right? This must be together. Or means both condition must be satisfied, then only you write from the left array to the main array. Or if the j is more than equals to n2, or if this array has already been iterated, all means all the element has already been iterated from here, then also you have to take the values from here. So if j is more than equals to n2, then also we take the value from here. Otherwise we take all the values from here. So now this actually makes the entire working of the merge sort. So here we have seen that how we are dividing each arrays into smaller parts, and then how we are merging it to get into the finally sorted array. So the main logic that is actually visible here is done by the merge procedure. So you can say that merge procedure is actually the heart of this algorithm. And also you will observe that we are doing n comparison. So if we have array of size n, we made two arrays. Either they may be n by 2, n by 2, or they may be equal, or they may be of different size, but the total size means this n1 and n2, this total size must be equals to n. Okay, because this array is only derived from this entire array. That also means that the total number of comparison that we are doing, we are only doing total n. That depends on the size of the array. Okay, so this is how the things are working. Let us talk about its performance, its analysis in terms of the time and the space.